Part A, how many different arrangements are there of the 11 letters in the word requirement? Okay, so R is there twice and E is there thrice, and other than that, we have 6 more numbers. Yeah, so that makes 11. Okay. So for part A, there we have to arrange these 11 letters. So it's going to be 11 factorial divided by repetitions, which is 3 factorial times 2 factorial, which gives 3326400. Part B is how many different arrangements are there of the 11 letters in the word requirement in which there are 2 R's together and 3 E's are together. Okay, so when 2 R's are together, we group them. They have an arrangement of 2 factorials, and then we group the 3 E's and they have an arrangement of 3 factorial. Apart from that, we have 6 more alphabets. So 1, 2, 3, 4, 5, 6. Now, after grouping, this counts as a single alphabet and this counts as a single alphabet. So these would have an arrangement of 8 factorial, 6 and then 7 and then 8. Yeah, 8 factorial. So the answer would be 2 factorial times 3 factorial times 8 factorial divided by repetitions, which is 2 factorial and 3 factorial. So the answer would just be 8 factorial, which is 40320. Okay. Part C. How many different arrangements are there of the 11 letters in the word requirement in which there are exactly 3 letters between 2 R's? Okay, again, we'll have to group it. We have R, 3 letters, and another R. So we have for R and R, we have 2 factorial, but again, we have repetition so that 2 factorial will divide later. Anyway, times this is going to be, now take away the 2 R's, we're left with 6, 7, 8, 9, 9 alphabets. So this would be 9P3. So this group becomes, it has arrangements of 2 factorial times 9P3. Okay, now this becomes a single alphabet. Now this will count as single alphabet. And apart from these, how many do we have left? We have 6 left, 6 more alphabets left. Yeah, so that the total becomes 11. Okay, now this would be 6 plus 1, because this now counts as 1 only. So 6 plus 1, 7 letters. So they'll have 7 factorial arrangements. So we times this with 7 factorial divided by the repetitions, which is 2 R's and 3 E's, which gives 423360. Okay. Part D. How many possible selections contain at least 2 E's and at least 1 R? Okay. Now that would be at least 2 E's. So we can take E and another E, then another R. Okay. And we are selecting 5 out of these letters. 5 of the 11 letters in the word requirement are selected. How many possible selections contain at least 2 E's and at least 1 R? So we have an E, E, R, and then we'll have 2 more alphabets. Either that, or we could have 3 E's and an R and 1 more alphabet, or we could have 2 E's, 2 R's, and another alphabet, or we could have 3 E's and 2 R's. Okay. So E and E would be just 2C2 or 1C1 into 1C1. So 2C2 is actually just 1. Okay, then R would just be 1C1, which is again 1, so we don't have to write that. So all the selections would come from these two. Now here we'll have, take away the R's, take away the E's, we'll have 6 more alphabet left. So we'll have 6C2 selections here, which is 15. Okay, here we'll have 6C1 selections, which is just 6. Here also we'll have 6C1, which is 6. And this is just one selection. So this is 1. So we'll do 15 plus 6 plus 6 plus 1, which is 15 plus 13, which is 28.